work of the summit. Now I have the really distinct honor to introduce for a brief moment James Hansen. And I consider him, having read a good amount of his work, as an excellent scientist, and even more importantly, as a courageous scientist. There are not too many scientists who have the characteristics of boldness and courage to speak to the powers that be. So many of you will remember how a couple of years ago, how the Bush administration, EPAs, so the EPA, public relations, I think, in the Bush administration, was editing James' scientific conclusions, which was covered, of course, in New York Times, and rightly so. But most people may forget that he has been at this for the last, let's see, in the mid-70s, so that is about 30 years. He has been dealing with this. And in the 80s, he was the one who was able to present this to the US Congress, to the US Senate, particularly by the efforts of Timothy Worth, of the Senator of Colorado, who is now the president of the UN Foundation, really a visionary fellow American. And so that is James's past. Excellent science, courage, and boldness. As a matter of fact, as mentioned also in the front of the folder, he is proclaimed by the World Watch Institute as a climate hero. And of course, many people are made heroes and heroines, but the real ones, there are not too many, unfortunately. But in my opinion, James is surely one. James, we are really looking forward to your wisdom, to your science, and we thank you for your courage.
So you just need to move the arrows. You can try it now by, well, I should note that my title of my talk is a little different, I notice, than is in the program. I will address the topics indicated in the program, but I also like to emphasize this question of intergenerational equity and justice. I think that the climate crisis, as you correctly describe it, is in fact potentially a source of enormous injustice and inequity for the younger generations and the unborn. So let's, if you just put the forward arrow, I have children and grandchildren, and this is the newest grandchild whose birthday party is tomorrow. So I'm going to Virginia Tech later today, and I have to get back in time for his first birthday party tomorrow. But it's because of my grandchildren that I decided 4 years ago to speak out in a public way on this topic. I had, as was mentioned in the introduction, I had testified in 1988 to the United States Senate, and that got a lot of public attention. And I testified the next year to Al Gore's committee. And if you saw the movie An Inconvenient Truth, if you didn't blink, I was in there for about 2 seconds. It was a little misleading, the clip that was used in Inconvenient Truth. What had actually happened was that the night before my testimony, I sent a fax to Al Gore and requested that he ask me about some specific lines in my written testimony because I said that I wanted to make clear that those statements were not my statements. They had been inserted by the White House. And so that got a lot of attention also on the front page of the New York Times. And I decided at that time that I wanted to get back to doing science. And so for 15 years, I assiduously avoided, after 1989, all the requests for television interviews and things. I prefer to leave that to people who enjoy it, like Steve Schneider. There are some climate scientists who actually enjoy the public aspect of it, but that's not my, I'm a rather shy person, and I prefer to do science, which is where what I think I can do well. And so I got out of that business for 15 years. And it was not until 2004 that I decided that let's flip to the next chart, that because a large gap had developed between what is understood about global warming by the relevant scientific community and what is known by the people who need to know, and that's the public and policymakers. And it's not obvious to the person in the street, but in fact, it is a planetary emergency. And the reason, part of the reason that it's not obvious is that weather fluctuations are larger than global warming at this time. So you don't notice that much happening. But that's partly because of the inertia of the climate system. The ocean is 4 kilometers deep, so it takes it a long time to respond as humans begin to force the system. It takes many decades to get close to the full response. And the problem is that the climate system has tipping points. And you can reach a point where the dynamics of the system begins to take over. A good example is ice sheets. If Greenland and Antarctic ice sheets are a couple of miles thick ice, very large volume of ice, and it responds slowly. As the planet starts to get warmer, it responds only slowly. But once disintegration gets underway and the ice sheet begins to slide down the slope toward the ocean, then the dynamics of the system takes over, and it doesn't matter. You can't solve the problem by reducing your greenhouse gases at that point. It's too late. So you don't want to pass tipping points. And what I'm going to try to make clear is that the tipping points for the amount of atmospheric carbon dioxide is a lot lower than what we thought. Only in the last few years have we realized how low the dangerous level is. For the last 10,000 years, the amount of CO2 in the atmosphere is about 280 parts per million. It's now 385. So humans have increased it by burning fossil fuels from 280 to 385 parts per million. And what I'm going to show you is that the dangerous level is we've already passed the dangerous level. We're going to have to actually, if we left the atmospheric CO2 at its present level or higher, we would get some very undesirable effects, as I will discuss. So we're actually going to have to figure out how to reduce CO2 in the atmosphere, and that is still possible if we begin to act promptly. And the things that you need to do in order to reduce the CO2 actually make sense for other reasons and have multiple benefits in terms of improved agricultural productivity and human health. Let's flip to the next one. Okay, so in 2004, 4 years ago, early in 2004, I made the conscious decision to speak out publicly, because I had had the opportunity between 2001 and 2004 to to speak with the government. I met twice with Vice President Cheney and 6 cabinet members who formed the Energy and Climate Task Force. And then in 2003, I made a presentation at the White House to the Council on Environmental Quality. And what I realized by that time was that the policies were being set independent of what the scientific evidence indicated. And instead, there was more of an attempt to try to get the science to fit the predetermined policies. So I decided I wanted to make a public talk and write a paper for Scientific American and other journals to try to make this story clear, that we had actually reached a point where we needed to do things promptly, or we're going to guarantee for our children and grandchildren very large undesirable consequences. So I got my 2 grandchildren at that time to help me to try to illustrate the greenhouse effect. The gases that we add to the atmosphere, especially carbon dioxide, absorb infrared heat radiation, so they trap the Earth's heat and cause the planet to be warmer than it otherwise would be. And it's equivalent, the amount that we've added to the atmosphere is now equivalent to 2 watts per meter squared, the Earth absorbs about 240 watts per meter squared of energy from the sun. So this trapping of heat is approximately equivalent to increasing the brightness of the sun by 1%, which doesn't sound like a lot, but it's equivalent to having 2 of these tiny Christmas tree bulbs, which are, some of them are about 1 watt per meter squared. So Sophie was explaining to Connor about these 2 watts of human-made heat. Let's flip to the next one. And by the way, that's 4 years later. Those are Connor and Sophie. But let's go to the next one. As I mentioned, the Earth is now getting warmer in response to this increased greenhouse gases, but the warming is small compared to weather fluctuations. The temperature from one day to another can fluctuate by 10 degrees or more. Even if you average the temperature over a month, the temperature anomalies can be positive or negative. They can be warmer than normal or cooler than normal at a given place. These are just maps of the last 4 months, and there are more places that are warmer than normal, and normal is defined as the 1950 to 1980 average temperature. So there are more places that are warmer than normal than cooler than normal, but still you can have a given month which is unusually cool. But could I have the next chart? But if you average the temperature over the first 7 years, first 8 years or 7 years of this millennium, 2001 to 2007, then you can see the warming very easily. It's getting warmer everywhere, with the warming larger at high latitudes than it is at low latitudes, because at high latitudes there are amplifying factors. As the planet gets warmer, the ice and snow melt, and that reveals a darker surface, and so the surface absorbs more sunlight, and that's a positive or amplifying feedback. And the warming is larger over land than it is over the ocean, because the ocean has a large thermal inertia, so it takes it longer to warm up. Could I have the next chart? And if you average over the planet, then the planet is getting warmer. It's warmed by about 0.8 of a degree Celsius, which is about 1.5 degrees Fahrenheit. And most of that warming has occurred in the last 30 years. 75% of the warming. And that doesn't sound like a lot, but in fact it has important impacts, and furthermore, there's a lot more in the pipeline. We've realized less than half of the eventual warming due to the gases that are already in the atmosphere, just because of the inertia of the climate system, which is primarily due to the deep, 4-kilometer deep ocean. So could I have the next chart? Nevertheless, 1.5 degrees or even a few degrees doesn't sound like it's necessarily a problem. So why should we be concerned about human-made climate change? Because we know that there have been times in the Earth's history when the climate has changed much more than that. So isn't it arrogant for us to think that humans can control the climate, or that we know enough to say that today's climate is the best one for the planet? These are sensible statements that you, questions that you might ask. And in fact, I took these statements from statements made by the NASA administrator, my boss's boss's boss, on National Public Radio last year. And it indicates that we scientists have not done a very good job of making clear what the implications are. So let me try to do that. And I want to say a little bit, if you go to the next one. The basis for our understanding is not primarily climate models. That's what the skeptics or contrarians will say. But in fact, our knowledge comes primarily from the history of the Earth and how the Earth responded in the past to changes in atmospheric composition and other boundary conditions. And also, we can observe what's happening now to the changes from 280 to 385 parts per million of CO2. We can, those are our best sources of information, and the climate models help us also to interpret those things. Could I have the next one? And let me say a little bit about the history of the Earth. This shows the temperature over the last, see if I have a pointer, over the last 400,000 years. We're now living in the Holocene, which is a relatively warm period. The temperature goes down over a period of 100,000 years, and then it warms up rapidly. And this happens repeatedly. And we've been in this warm period, the Holocene, for almost 12,000 years now. The last ice age, 20,000 years ago, there was an ice sheet that covered Canada, and New York City was under about 1 kilometer of ice. Minneapolis and Seattle were all under this same very large ice sheet. There was so much water locked up in this ice sheet and another ice sheet on Europe that sea level was about 110 meters or 350 feet lower than it is now. And those are natural climate changes. Those changes are, so, and I could give a 1-hour talk on just this, but I want to just summarize it in a couple of charts. These changes are due to small perturbations in the Earth's orbit. The Earth's orbit about the Sun is perturbed by Jupiter and Saturn, which are very heavy, and by Venus, which comes close to the Earth at certain times, and that causes the tilt of the Earth's spin axis to wobble by a small amount, just plus or minus 1 degree. But when it's tilted more, then there's more sunlight on the high latitudes, and that tends to melt the ice sheets. And also the eccentricity, the Earth's orbit is not exactly circular, and it changes its degree of non-circularity. And that will cause ice to melt or to grow in the case at the poles, in the case when the spin axis gets tilted less. And as ice and snow melt, then the planet absorbs more sunlight. The darker surface absorbs more sunlight, so that causes warming. And as the planet gets warmer, as the ocean gets warmer, it gives up carbon dioxide, just like your soda, your Pepsi will give up its CO2 if it gets warm. And as the planet gets colder, then the ocean takes up CO2. And so it turns out that could I have the next chart? The mechanisms, so the instigator of these climate swings is the Earth's changes, perturbations to the Earth's orbit. But the mechanisms that actually cause the large temperature changes, which are about 10 degrees temperature change between the Ice Age and the interglacial period, there are two mechanisms. One is the change in these greenhouse gases, and the other is the change in the reflectivity of the Earth's surface. As the ice and snow melt, the surface is darker, it absorbs more sunlight. So those two mechanisms actually determine these changes. And of course, a confusing thing about Al Gore's Inconvenient Truth, and the contrarians, after watching that movie, say, oh, this has got to be completely wrong because, in fact, the temperature changes occurred first, and then the greenhouse gas changes. Well, yeah, in this natural case, the instigator is the changes in the Earth's orbit. That causes ice and snow to melt, which causes it to get warmer, which causes more CO2 to come out, and then that causes it to get still warmer as a positive amplifying feedback. And so in that case, the sequence of events is as I just described. But now, could I have the next chart? But now what the humans are doing, what we are doing is now CO2, this is now the last century. This is 400,000 years, and now here's the most recent century. And we, by burning fossil fuels, have increased CO2 far outside the range that it has existed in millions of years. And so we're now in control of climate change because these, and in addition to the greenhouse gases increasing far outside of their natural range, ice and snow are melting all over the planet. So the two mechanisms that cause the global climate change are now under the control of humans. And we're not going to see another ice age. Could I have the next chart? And let me just say one more thing about paleoclimate. And that is to look at a longer time scale, because this gives us the opportunity to see a case where the greenhouse gas changes do lead the climate change. In the case of the ice ages, which I just showed you, in that case, the carbon dioxide is oscillating between being in the ocean or being in the atmosphere. Carbon dioxide is contained in the atmosphere, in the ocean, in the soils, and in the biosphere, in the trees. And on these timescales of hundreds of thousands of years, the CO2 can move between the ocean and the atmosphere, but the total amount is more or less fixed. However, if you look at still longer timescales of many millions of years, then the total amount of CO2 in these surface reservoirs can change, because what determines the amount of CO2 in the atmosphere and the surface reservoirs is exchange with the solid Earth. The carbon dioxide source is volcanoes. And that occurs in conjunction with continental drift. As the continents move and subduct beneath them the ocean crust, that carbonate-rich ocean crust, there's a metamorphosis. The strong heat and pressure of the continent over top of the ocean crust causes a metamorphosis of the carbonate sediments and forms basalt and other rocks and releases CO2, which comes out in volcanoes and seltzer springs that are associated with the volcanoes. sink, the thing that takes CO2 out of the surface reservoirs, is weathering. As the sediments, as weathering occurs on the continents and the rivers carry sediments to the ocean and deposit it on the ocean floor, that process deposits carbonate sediments on the ocean floor, and the chemical reactions that occur with that weathering process store carbon dioxide on the ocean floor. But those two processes, the volcanic emissions and the weathering sink, do not need to be in exact balance depending upon what the continental drift is doing. And in particular, if we look at the last 65 million years, this is a graph of temperature over the last 65 million years. And these oscillations are the ice age to interglacial oscillations that occur due to the Earth's orbital changes. But there's a long-term change which has occurred with the planet being much warmer 50 million years ago. This time goes from 65 million years ago to the present. And the planet has been cooling off for the last 50 million years. During this time period, there was no ice. The planet was much warmer than it is now. There was no ice on the planet, not even on Antarctica. Could I have the next chart? The reason is that 65 million years ago, at the end of the Cretaceous, after the age of the dinosaurs, the continents looked like this. They were already close to their present latitudes, but still India was located south of the equator, and it was moving north at a rate of about 20 centimeters per year, which is very fast for continental drift. And it crashed into Asia 50 million years ago. So as India was moving north, it was going through this region, which was then called the Tethys Ocean. It's now the Indian Ocean. But that region had been the depot center for rivers carrying sediments to the ocean for millions and millions of years. And so the ocean floor was a very carbon-rich ocean floor. And as India plowed through this ocean and subducted ocean crust, it was fuming CO2 into the atmosphere through volcanoes. And so if you back up one, so what was happening as India was moving through the Indian Ocean, the planet was getting hotter and hotter as the CO2 increased. And then India crashed into Asia and began to push up the Himalaya mountains and the Tibetan plateau, which it continues to push now and continues to push them higher. So from that point on, the weathering, the source of CO2 from the continental drift was diminished, and the sink through the weathering of the Himalayas and the Tibetan plateau drew down the amount of CO2 in the atmosphere. So CO2 decreased and the planet cooled off until it reached a point 34 million years ago when it became cool enough that ice began to form on Antarctica. And then due to the amplifying feedback of a higher albedo Antarctica, the Antarctica froze over rather quickly. And that's, so if I could have the next chart. So my point is, and then let's go to the next one. One interesting fact is that, well, how far did CO2 have to decrease? CO2 at this time was more than 1,000 parts per million. As I said, it's now 385 in the last 10,000 years it was 280. Now by burning fossil fuels, we've increased it to 385. Well, back here it was more than 1,000 parts per million. And by the time it had decreased to about 450 parts per million, that was low enough that ice could begin to form on Antarctica. So if I could have the next chart, this is the conclusions I want to emphasize from this paleoclimate data. Naturally, the dominant forcing that caused climate change on these long time scales is natural changes in atmospheric carbon dioxide. Those changes naturally occur at a rate of about 1/10,000th of a part per million per year. And over 1,000,000 years, that becomes 100 ppm of CO2, which is a large change. But now let's compare that with what humans are doing. We are now increasing atmospheric CO2 at a rate of 2 parts per million per year. So we are 10,000 times or 20,000 times more powerful than the natural rates of change of atmospheric carbon dioxide. So humans overwhelm these natural changes. So although it was a reasonable question for the NASA administrator to ask and say, haven't there been larger climate changes? Yes, there have been much larger climate changes, but those occur very slowly over very long timescales. We have taken over completely. We are much more powerful than the natural rates of change, and we are going to determine what the future climate is. And if we burn all the fossil fuels, and the energy departments take it as a God-given fact that we're going to burn all the oil and all the coal, if we do that, we will more than double or triple the amount of CO2 in the atmosphere. And we would produce, which would be much more than 450 parts per million. So the planet would be headed toward the ice-free state, which would mean a sea level rise eventually of more than 70 meters, which is more than 200 feet. So we can't do that. We would produce a completely different planet if we burn all the fossil fuels without capturing the CO2. So could I have the next chart? Now let's talk about a little more practical things. In 1992, all the nations, or 170 nations in the world, essentially all the nations, agreed to this framework convention on climate change. They said we should avoid dangerous human-made interference with the climate system, but no one defined that. So let's have the next chart. I think that the metrics for defining what is a dangerous climate change should include those things which are irreversible on any time scale that humans would care about. And that would include extermination or extinction of species. There have been times in the Earth's history when there was global warming of several degrees Celsius, and that caused more than half of the species on the planet to go extinct. The species attempt to migrate, to stay within a climate zone that they can live in, but if the change is too large, then it begins to cause some of them to go extinct, and then because they depend upon each other, you can have ecosystems collapse and you lose many species. Well, in the natural world, after mass extinctions, new species come into being, but it takes hundreds of thousands of years. And so for any time scale that we can think about, or our descendants can think about, if we drive species to extinction, it will be a much more desolate planet for any time scale we can think about. So another irreversible effect is ice sheet disintegration, because ice sheets on Greenland and Antarctica build up from snowfall that piles up year after year. But it takes thousands of years, tens of thousands of years, to build up these thick ice sheets. So if we cause Western Antarctic ice sheet to slip into the ocean, and raise sea level. In the case of Western Antarctica, it would be 6 to 7 meters of sea level rise, or about 20 to 25 feet. That would be a permanent change for any time scale that humans can think about. So we don't want that to happen. And there are also regional climate changes that are important. Could I have the next one? And the problem is that there are tipping points in the climate system. And there are two aspects of this that I need to mention. One is the tipping level. We can estimate what level, what amount of greenhouse gases would be needed in order to cause a given effect, because we can look at the Earth's history at times when the system has had time to respond. And so we can estimate the amount of greenhouse gases that would be needed in order to cause a given change. But what's harder to estimate is how long it takes the climate to respond to that change. For example, if we increase the amount of CO2 in the atmosphere to 1,000 parts per million and just leave it there for a day, well, that's not going to cause the ice sheets to disintegrate. It takes some time to respond. So it's a question of when do you get to a point of no return where the dynamics of the system, when the ice sheets have begun to disintegrate and are moving down a slope. That's a harder problem, the point of no return. But could I have the next chart? But we have reached that point of no return in one part of the climate system, and that is the Arctic sea ice. The amount of sea ice in the Arctic fluctuates from year to year. We have precise data, satellite data, going back to the late 1970s, and the amount of sea ice fluctuates from year to year, but now in the last 2 years it's been reduced to only about half of what it was in the 1970s. And unfortunately, we are going to lose all of this Arctic sea ice in the summer because we know that the planet is now out of energy balance. There's more energy coming into the planet than there is going out because of the greenhouse gases that have been added and because of the time that it takes it to respond. These two light bulbs that Sophie was holding up, that planetary energy imbalance is going to cause us to lose over the next few decades the remaining summer sea ice. But this is a reversible problem. Could I have the next chart? If we were to reduce the amount of CO2 in the atmosphere so that this planetary energy imbalance was removed, then if you make that imbalance slightly negative instead of positive, then the planet cools off and the sea ice can reform. If we wanted to stop further melting, we would have to reduce CO2 from 385 parts per million to something like 300 to 350 parts per million. Could I have the next chart? Another criterion for estimating how much CO2 we should be aiming for is the stability of these large ice sheets on Greenland and Antarctica. And the amount, the red area on Greenland, this is the area which has summer melt, in this case in the year 2007. The area that has summer melt fluctuates from year to year, but it's been increasing in general over this time period which we have satellite data. And in 2007, it set a record. It was twice as big an area with summer melt. Could I have the next chart? And that summer melt does not make it to the edge of the ice sheet. It finds a low spot on the ice sheet and it burrows a hole in the ice sheet which goes all the way to the base of the ice sheet. And then, could I have the next chart? The effect of that meltwater is then to lubricate the base of the ice sheet and speed up the discharge of these giant icebergs to the ocean, so that could I have the next chart? The ice sheets are now losing mass. Until we had this recent satellite called GRACE, which measures the gravitational field of the Earth with a very high precision. such a high precision that we can measure the mass of ice on Greenland and Antarctica. And as we would expect, during the winter, as the snowfall piles up, Greenland gets heavier, and then it loses mass during the melting season, and then gains mass again the next winter. But overall, it's losing mass at a rate now of about 200 cubic kilometers per year, which sounds like a lot, but it's only about a millimeter of sea level when you spread it over the whole world. Could I have the next chart? But sea level is now rising at a rate of about 3 centimeters per decade, which means that's a little more than an inch per decade. And in a century, that would be 30 centimeters, so it's something, 34 centimeters, which is something more than a foot. It's a little more than a nuisance, but the danger is that the ice sheet will begin to collapse and you get much larger sea level rise. In fact, if we look at the mass balance of Greenland over the period from 1990 to the present, the data, early data, we didn't have that satellite, but we have cruder measures of estimating the mass balance. And it was nearly in mass balance if you go back to 1990. But now it's losing mass faster and faster. And the danger is that it could, that the rate of sea level rise has doubled in the last 2 decades, and the danger is that it could double a few more times, and then you're talking about meters of sea level rise, and that would be a huge problem. Could I have the next chart? And so, sea level tells us if we want the ice sheets to be stable, we probably would like CO2 of the order of 300 parts per million. In any case, 385 parts per million, the present amount, is clearly dangerous. Could I have the next chart? Other effects, another effect of global warming is that the overturning circulation, on average, there's rising motion in the tropics and subsidence of air in the subtropics. That's what causes the subtropics to be dry. But that overturning circulation expands as the planet gets warmer. And we already have seen on the average that this expansion is about 4 degrees of latitude, which is about 400 kilometers or 250 miles. That's already beginning to affect the southern United States and the Mediterranean region and Australia and parts of Africa. And so the fact that this is Lake Mead and there's no longer any water underneath this pier, but Lake Powell also is only about half full now. And could I have the next chart? And the forest fires in these regions, the western United States, have increased by a factor of 4. Depends on the weather, so it fluctuates from year to year, but there's a long-term increase, and that's also occurring in Canada and Siberia. It's another effect of this higher temperatures and increases in the hydrologic extremes. Could I have the next chart? One of the most important effects is the melting of the mountain glaciers, because the mountain glaciers in the Himalayas and in the Rocky Mountains and in the Andes Mountains provide fresh water through the entire summer and fall season. And that that freshwater supply is threatened by the melting of these glaciers. These winter snowfall will continue to occur even if the glaciers are gone, and you will get heavy runoff and floods in the spring because snowfall actually will increase. The atmosphere holds more water vapor as the planet gets warmer, just as the summer has more water vapor than the winter. But if the glaciers are not there, then after the spring season, the rivers will run dry. And now, could I have the next chart? So as a function of, this is the glacier size as a function of altitude at different glaciers around the world. And so far, we've lost this black portion of the glaciers. So at the rate they're now melting, we will lose these glaciers within the next several decades, which will have a big effect on freshwater supplies. So again, if I could have the next chart. Again, this tells us, well, that we would like CO2 to be less than it is now if we want those glaciers to survive. Another effect is on coral reefs. Coral reefs are the site for about 1/3 of the species in the ocean are associated with coral reefs. And coral reefs are now under stress for several different reasons, but the two of the most important reasons are that the ocean is becoming more acid. As CO2 increases in the atmosphere and is taken up by the ocean, it makes the ocean more acid, so that the species that have carbonate shells or carbonate skeletons are threatened by this increased acidity, which in effect dissolves their skeletons, their shells. And also the increasing temperature is causing stress on coral reefs. So, if I could have the next chart. So all of these things tell us that we really should be aiming for a atmospheric CO2 of less than 350 parts per million, perhaps as low as 300 parts per million. And this probably shouldn't be surprising, because the last, the Holocene, the last 12,000 years, CO2 was 280 parts per million, and that's what life had developed to live with. And so it shouldn't be surprising. If in fact we continue to increase CO2, we're going to cause enormous stress for life on the planet and exterminate a large fraction of life on the planet. Could I have the next chart? So the target should be less than 350 parts per million. Could I have the next one? The problem is with burning fossil fuels, as a pulse of CO2 is put in the atmosphere by burning fossil fuels, the portion that stays in the atmosphere decreases to about 1/2 within about 20 years. But then the rate at which it disappears slows down. Most of it, where it's going, is into the ocean. But the CO2 that's taken up by the ocean then exerts a back pressure on the atmosphere. It can come back out. So until the CO2 in the ocean ends up as sediments on the ocean floor, the ocean resists taking up the additional CO2. And even after 1,000 years, about 20% of the human-made pulse is still in the atmosphere. Could I have the next chart? And that's the problem. So if this bar graph shows the amount of CO2 contained in oil, gas, and coal. And the dark portions are what we have burned already and put into the atmosphere. And that's what has caused CO2 to increase from 280 to 385 parts per million. Well, if we're going to keep CO2 from increasing more and get it to decrease, the simple conclusion is we cannot burn the coal. It's going to be very difficult to stop burning the remaining oil, because that's owned by Russia and Saudi Arabia and Middle East countries. You're not going to convince them not to sell their oil or to use it themselves. But if we would put a moratorium on new coal-fired power plants and phase out the existing ones between now and 2030, and we could still burn coal, provided we captured the CO2 and sequestered it under the ground, then that phase out of coal would cause CO2 to peak at no more than 425 parts per million, maybe only 400, depending upon whose estimate for how much oil there is left in the ground is more accurate. CO2 would peak at around 400 parts per million. And by means of and then it would slowly begin to decrease. It would still stay over 350 parts per million for a couple of centuries unless we take some additional steps by means of improved agricultural practices and forestry practices, and especially reforestation of some of the areas that we've deforested. We could get the CO2 to decrease below 350 within several decades. So could I have the next chart? So it's technically feasible to solve this problem, but it requires a quick phase out of coal. Could I have the next one? And this just emphasized that most of the CO2 in the atmosphere comes, surprising to people, but most of it comes from coal. People think we've stopped using coal, but we haven't. We're actually using more and more coal all the time, but it's being used at power plants, not in your stoves. Could I have the next one? And most of this, you know, China just passed us. This is the current emissions of CO2. China is now slightly larger than the United States. However, the excess CO2 in the atmosphere depends upon historical emissions because it stays there 1,000 years. So if we look at who's responsible for the excess CO2 in the atmosphere, the United States is more responsible than any other country by more than a factor of 3. So we really should be leading the solution. Could I have the next one? And on a per capita basis, we're more than 10 times more responsible than countries like India or China. Could I have the next one? So the things that would be needed, we could, although energy companies and the government tells us that it's inevitable that we're going to burn all these fossil fuels, the truth is we could have a free will solution. That would require phasing out the coal CO2 emissions. And frankly, it also requires a carbon price, because otherwise we will end up burning start using the unconventional fossil fuels like the tar shale in the Rocky Mountains. We'll start cooking the Rocky Mountains to produce oil. We're going to, could I have the next chart? But you know, we're going to have to move beyond fossil fuels anyhow. There's not more than, even the most optimistic estimates would say there's about a century's worth of fossil fuels if you use all the coal and unconventional fossil fuels. So we're going to have to move beyond those anyhow. So why not do it sooner and preserve life on the planet? But basically there's a conflict, I think, between the fossil fuel special interests who are making money from burning fossil fuels and young people in nature. Could I have the next chart? So that makes it a tough battle, because fossil fuels have tremendous influence. Money talks in Washington and other capitals, and young people and nature don't have much voice, and the animals don't help much. They don't vote and they don't talk. Could I have the next one? As I said, you know, we're going to have to figure out how to live without fossil fuels someday, so why not move more quickly to the post-fossil fuel era? Could I have the next one? And we need a strategic approach. Could I have the next one? And as I said, the principal thing that's needed is to phase out coal emissions. And coal is very dirty stuff, by the way. No one's figured out how to capture the mercury that comes out of coal-fired power plants, and that's the reason why you're told not to eat too much fish now, because we're polluting the global oceans. And so it only makes sense to move beyond this coal and fossil fuels to cleaner energies. And it does require a tax on carbon, but I claim the public will only accept that if you give that money, 100% of it, back to the public. And you can do that on a monthly basis, but deposit it in their accounts. And you do this on a per capita basis, and that way, those people who do a better job than average in reducing their carbon emissions will actually make money. So what you don't want is a tax and then the government decides on how to use that money. What you want is to give it 100% of that money back to the public on a per capita basis. Could I have the next one? As I mentioned, there's an intergenerational inequity. Our parents did not know the consequences of what they were doing. That defense is no longer viable. We now realize what the consequences are going to be. And that raises ethical and, I think, legal liability questions. The reason is, I think, there are companies like ExxonMobil and Peabody Coal which have actually tried to misinform the public and have paid money to people who will deny scientific facts, and that has confused the public because they hear that we don't know what's going on when in fact we do know what's going on. And the political process has not been working very well. And of course the political process is not even available to people who are too young to vote or who are not yet born. Could I have the next one? And I think we're likely to see increased public protests. This is showing 6 people who, actually 5 of them, climbed this stack at Kingsbridge North Power Station in United Kingdom, and they wrote on the stack, they were writing Gordon Bennett. Gordon Brown is the Prime Minister of England. And however, before they got the sign completed, they were arrested and then charged with causing $65,000 worth of damage because the stack had to be repainted. But I went to England to testify on their behalf, and I could have the next chart. And these are the 6 people. And anyway, there was a jury of 9 women and 3 men, and the jury decided that they were not guilty because the rationale was that you're allowed to destroy property to protect greater property. And if you knock down somebody's door in order to put out a fire behind the door, that's not considered illegal. And now there are now some cases in the U.S. There's going to be a trial, I think, next week or the week after that in Ohio, where young people were arrested for sitting in a utility office where they're planning to make more coal-fired power plants. So I think this is going to be an issue in the next few years, and hopefully we can get a government that will change policies. Do I have another chart? Well, yeah, there's more information on my website, which you can find at this location. Thanks.
First of all, James, many thanks for this very broad approach to the climate crisis. Not only the scientific one, which of course covered about 3/4 of the presentation, and rightly so, but also bringing in the ethical aspect of intergenerational justice, which of course is also a part, as you will see, in the Earth Charter. And then thirdly, bringing in the political aspects. So this is very well done. And though we are only about 3,000 or 4,000 people here, this will be distributed nationally and internationally what James had to say. And so now we have another 10 minutes or so for questions and answers. And so let's go to the first question. Let me see what we can do in terms of amplifying your sounds.
Well,
did everyone hear the question? So maybe what we ought to do, those people who have a question, please come up here and ask the question up here.
Yeah, or I can repeat the question. The question was whether the extraction of the fossil fuels from the earth has negative impact on the earth. Well, one interesting aspect of in Galveston, Texas, and some of the places in Texas which had quite a lot of oil in the ground, and the extraction is causing subsidence of the land by over a century by about a meter. So that kind of adds to their sea level problem. As the ocean comes up and as the land sinks, then they have a bigger problem. But the real big problem with extraction is, I think, concerned with coal. If you look at the techniques that are used with mountaintop removal, the coal is really dirty stuff. It's got heavy metals in it, and pollution of the streams. There's been 100 times more radioactive material released to the environment by burning coal than by nuclear power plants. It's very dirty stuff, and that the fact that many children have more birth problems has a lot. I think probably has a lot to do with the pollution of the environment, both air and water, and the biggest contributor to that is coal. So I think it would be great if we can move beyond that source. Right now, China and India are using more and more and burning it and pumping stuff into the atmosphere, which reaches all the way to the United States. The air currents carry it here. So, but anyway, I'm kind of wandering from answering your question. But yeah, there are some impacts of both the oil extraction and the coal extraction.
Okay, Olive, and then we will take 2 or 3 on that side.
Okay, the question was, what do we do about it? And in particular, isn't population a big part of the problem? And I mean, it is true that the emissions are more or less proportional to the population. But I think that part of the problem is potentially solvable. Actually, in developed countries, the United States is an exception. Our population is still going up quite rapidly, mainly because of immigration. But in most developed countries, the fertility rate has declined to something comparable to the replacement level, and in some countries it's less than the replacement level. The population in many of these countries is still going up slowly because the people live longer. But it looks like there's a good chance that and having many children is becoming unpopular with women almost worldwide. Even women who are not very highly educated. So I think the population is a good chance that it will peak at no more than 9 billion, and maybe less than that. And so that will no longer be a big driver, more than it is already. So the real issue is the fossil fuel emissions. We simply cannot burn and release to the atmosphere all of the CO2 from fossil fuels, and in particular coal. We would have to have leaders who understand that. And right now, countries all around the world are still increasing their use of coal. Coal use had begun to go down, but then over the last 10 years, it's begun to shoot up every place. Japan, Germany, even the countries that are supposedly the greenest, and they don't get it. There's this euphemism about clean coal. That there is no such thing as clean coal, and they only use that phrase. It's like clear sky and a healthy forest. It's a propaganda, but in fact, nobody has a coal plant, power plant that captures the CO2 and sequesters it. They just talk about maybe we'll make one of those in the future, but it's not anywhere near. So we really have to get governments to realize that, and that is the main thing. That's why young people are starting to stand in front of these new coal plants and try to block them, because they have correctly identified what is the dominant source of the problem, and the solution has to be a moratorium on any new coal-fired power plants and a phase out of those that exist. If we do that, then even with the population, we can stabilize the climate.
I see we have quite a lot of questions, and we have another 10 minutes. And given that James is emphasizing young people getting involved, I take a little privilege here as chair to ask him about the organization of Bill McKibben, which is called 350.org, which is based basically upon James's work. So they are basically globally organizing. So I would like to have James talk about this for a moment.
Yeah, thanks very much for reminding me about that, because I basically do science and give science talks, but if you want to get more practically involved, then Bill McKibben is working with young people and other people on this organization 350.org, which you can easily find. It's just the number 350.org, and they're doing various things to try to inform the public and to try to put pressure on governments to take the actions that are needed to preserve the planet for the future generations.
Okay, 1, 2, 3. Maybe we ought to take them together, and maybe some people might basically ask very similar questions. So let's do 1, 2, 3.
I have two questions. One about CO2 sequestration from coal-burning plants. Is the technology here? Can it be done as an alternative to phasing out or stopping them? And second is, could you elaborate a little more on overturning circulation? You mentioned it, but you really didn't tell us what it was.
Yeah, so we are taking the second one, Nidia, and then the gentleman.
My question is about methane and a recent article saying that people who are meat eaters are more responsible than coal-fired plants.
Okay. Next one, yes. Gentleman. Yes.
My question is, what do you see as the integration of science and religion and controlling this movement towards the tipping point? Because the biosphere is what's moving along with this, and it's the noosphere, thinking animal aspect of the biosphere, that's creating totally different lifestyles.
think we will stop with this one because they are all very strong questions.
Yeah. Okay. There was first question about sequestration. Is there technology for sequestration? And the answer is it's really not ready. You know, it was really the clean coal was a way for coal companies to pretend that the research was going on. So at the beginning of the Bush administration, in 2001, they started working on something called FutureGen, which was to be the demonstration plant for this technology. And in 2007, they canceled. They took them 7 years to decide where they're going to make the first one in Illinois. And as soon as they made that decision, they canceled the plans because they never really wanted to do it to begin with. It should have been called NeverGen because they didn't intend to do it. And it's possible that in the 10, 15 years we will have that technology. And that should be an option. If you tell utilities you can burn coal provided you capture the CO2 and sequester it, most of them will drop their plans because there are it's going to make it more expensive, and the technology is not ready yet, but it might be in the future. The overturning circulation, that's simply the sun heats the surface in the tropics and it causes air to rise, and you get therefore a very heavy rainfall in the tropical rain belt. But that same air then descends at the higher latitudes, around 20 degrees latitude, and that causes, of course it loses its moisture as it rises, and so as it descends, it's very dry air, and so the subtropics are dry. That's why we have deserts at the latitudes of about 20 degrees. Well, that overturning circulation, as the planet gets warmer, it expands, and so the subtropics will move poleward, and that's what we're seeing. That's part of the reason why the southwest United States is getting hotter and drier, because of that phenomenon. The methane. Methane is the second most important greenhouse gas after CO2. Actually, on a per molecule basis, it's even stronger than CO2, but there are fewer molecules. And it is true that meat eating, the process of if you're a vegetarian, you're contribute much less greenhouse gases than someone who's a meat eater, because in the case of animals, you have to grow the feed, and the total amount of energy used is much more to produce meat than to produce a vegetarian diet. And so you can contribute to reducing greenhouse gases by eating less meat. And both my daughter and granddaughter and daughter-in-law are vegetarians, and we've become sort of semi-vegetarian. We eat a little bit of meat, but minimize that, and that is a significant way to reduce your personal contributions to greenhouse effect. And the religion and the ethics, I think that's very important. Actually, I'm going to a meeting in Sweden of interdenominational religious leaders who are becoming more aware and active on this issue and trying to inform their congregations about what needs to be done. Yeah, it is, as I emphasized, I think it is an ethical issue.
Yeah, I see there are still many questions. Are there any press people here? I don't think so. But the press conference was planned to be concurrent with the breakout groups. And so we will break up in a minute, and I will tell you how we are going to do this. That is basically what we are trying to do for the rest of the day. I may also add that we were very happy to present James with a book called American Heat by Donald Brown, and it deals with the ethical implications of the US policy on global warming. And I also may add, I gave a presentation on the ethical dimensions of the climate crisis in Belgium in July for the International Peace Research Association. Anybody who is interested in that article and in the PowerPoint are welcome to give me their cards, and I will email it to them. And so I'm simply taking this opportunity now because this came up. So Donald Brown's book, American Heat, is a very important book in that regard. And he is the executive director of the Rock Ethics Institute, which brings together about a dozen institutions all over the world, which was started at the COP meeting in Buenos Aires a couple of years ago. So that last question, and also what you are going to do in Scandinavia, there is a real urge for people to start thinking in that regard. And that is basically the reason why we organized this particular summit. And not only here, but also all over the US and to some extent in other countries abroad. So we are now concluding the first part of our summit. And I suppose I speak for everyone that we may be so thankful for whatever spirit we believe in, that there is a James Hansen who for the last 3 or 4 decades has devoted his life to real scientific study and at the same time committing himself to boldly pronounce, or not pronounce, but announce his findings to the powers that be. So I invite everyone to really give him a good applause, a good hand for the excellent work. I see several people are standing, and I join them in standing, James. Many, many thanks.
With regard to the present candidates?
The presidential election,
Well, you know, the group that I'm going down to talk with at Virginia Tech is Power Vote, young people who are organizing in different states where there are clear differences between one Senate candidate and another candidate, or a House candidate and another. Because one of the big problems has been that the Congress is so under the influence of the fossil fuel industry that it's very difficult to get the actions that are needed. And so the young people are trying to use the democratic process, which is a logical first thing. Before you throw your body in front of construction of a new coal plant, you should try to use the democratic process, and that's what they're trying to do. Now, with regard to the 2 presidential candidates, they both, one of the vice presidential candidates doesn't get it, but both presidential candidates realize that there's a global climate issue, but both of them, I'm afraid, are partly dependent on special interests. And so we're going to have to really shine the light on what they're doing or not doing this next year. I have some hopes that we will really get on a different track with the new president, but but it's not guaranteed because it's amazing how much power the fossil. Yeah. Mail address.
Maybe you might still be around for a couple of minutes, James?
Yeah.
So what our program now is, we are going to be divided into groups, and it's very simple. We are with about 40 people, and so 10 people to a group, so there will be 4 groups.